Okay, boys. P.Eng. Darryl, yeah. Fellow life member of ASHRAE, was the ASHRAE president for the 2019 to 2020 term. Mr. BOYCE has previously served on the board of directors as treasurer, vice president, director, regional chair of Region 2, and director at Labs. More recently, Mr. BOYCE served as the chair of the Society Government Affairs Committee 2022-2023 and is currently the chair of the Society's Development Committee and the Headquarters Building Ad Hoc Committee. Mr. BOYCE is retired and was previously special advisor to the Vice President of Finance and Administration and the Assistant Vice President of Facilities Management and Planning at Charleston University in Ottawa, Ontario, Canada. Mr. BOYCE is a 1982 graduate at the University of Alberta with a Bachelor of Science in Engineering and earned his engineering diploma from the British Columbia Institute of Technology in 1973. I hope all that was true.
Yes.
Yes?
Oh, that's
all right.
Thank you.
Sorry about some of the communication issues of your expertise, but I mean, I'll try my best.
No, that's perfect, thank you. Well, good morning, everybody. In that last part, you heard about, I was a technologist, and when I graduated, just a little bit about that. When I went to the technology program, it was production, not HVAC&R. But my first job was in as a designer, mechanical systems designer, my first real permanent job. And the knowledge that you gained from ASHRAE at that time was reading the handbooks. So we've evolved considerably since then. So that training I had was becoming a mechanical system designer by reading the appropriate sections of the handbook. Anyway, so I'm here to talk about achieving net zero building in the ASHRAE headquarters building. And just to talk a little bit about it, it's where ASHRAE has actually said we're not just going to talk about sustainable solutions and doing the right thing, we're actually going to do that. And so I'm going to put a little context into it. So ASHRAE headquarters building has been located in the Atlanta, Georgia area for decades. And this is a picture of our building that we had around about 2005. We'd outgrown the space, so we actually renovated our building, added space, so we do some training at the actual headquarters building. So we were quite happy with this, and life was moving along. But what happened is that there was a major hospital development all around us. They bought every piece of property around us, and we became an island within a major construction of a children's hospital of Atlanta. So it was one of those things where they wanted our property. We were going to be not in a very good place if we couldn't sell it, so we eventually sold it. So we sold our property. We had an agreement to sell it. And then you kind of say, okay, what are we going to do now? So there are various options, right? You could lease space, you could build a new building, you could buy an old building and renovate it. And then the context that we talk about is that the bulk of the buildings that we have today will be around in 50 years. So we really said we should take a building that's in not very good shape and do something really good with it. And so the goal of the project, we bought a building. The building that we bought was empty for 2 years. A company had been bought out by another company, and then this building sat empty for 2 years. So it was just sitting there waiting for somebody to come along and save it, or it would be demolished. So we decided our project goal would be to renovate a 1970s building to be a great building, to have a great indoor environment and be effectively use energy. And then our organization relies on harvesting technical knowledge, and we also wanted to harvest the technical knowledge, but also provide it as a living lab, so to speak, to our members in the industry. So this is that building, 1970s building, and the domed area was quite interesting because that really is a 70s thing, and the heat gains and heat losses from that were substantial, so it was a bit of a problem. So our building that we had originally was 35,000 square feet. We we've done an analysis of space. We wanted more educational and training space, so we said we needed 45,000. This building was 66,000 square feet. So the bulk of it, about 45,000 was on the 2 levels that could be occupied effectively, and then there was a third level, low level, that could be used for storage. So it made sense for us to buy that building. We purchased it in December of 2018. So one of the key things, and we talk about this in our standards and guidelines, is to understand what your owner's project requirements are. So we made sure we followed our processes very well, and so we looked at the requirements, and job one is to have a safe and healthy work environment for our people and the visitors to the building. We wanted to have an affordable renovation reconstruction, so affordable to available funding. We wanted to meet or exceed some of our ASHRAE standards, meet all our ASHRAE standards, but exceed some of them. We found out in the other building that acoustics was a major factor, and we wanted to make sure we had improved acoustics in our new building. And we wanted to be net zero ready. So net zero ready, not necessarily net zero. So we wanted to be able to take the building to a low level of energy consumption while providing that great indoor environment. So those were the project requirements that we set forth. So this gives you a little bit of some of the things that we were doing. So we wanted to exceed some of the 189.1 requirement. Demand side energy consumption. Our target was 21.4 kilobtu's per square foot, US metrics. And we said if we were really good, we thought we could maybe get to 15. So these were the areas we wanted to. We wanted to have efficiency in terms of water. Daylight plug load, once the building was occupied, we wanted to have it at 0.4 watts per square foot. Acoustics exceed the normal office acoustics by 3 to 5 NC. Outside air intake, so this is where we're exceeding 62 by 30%, so we wanted 1.3 times. And that was before COVID, where the recommendations were that you provide more ventilation. It was just we felt that that would provide a better indoor environment. Not the minimum, but slightly over that. Outside air control, demand control ventilation. Daylighting, we wanted to have a majority of the space that's occupied have natural daylighting. And then achieve the resiliency as defined in our OPR. The other thing we discussed at the time we were doing the design is certification programs. So could we actually look at certification programs? So we looked at LEED, we looked at Green Globes, Well Building, Fit Well, and Living Building Challenge, and our ASHRAE Building EQ, and settled on the fact that we would just simply use our ASHRAE Building EQ as the primary way that we would assess our design and operation. So, as I said, we bought the site in December 2018. So we started our program really procurement and design in October of 2019. And then pricing, submission, and everything. So the thing, when we sold our building to the hospital, we had a drop dead date to get out. And that was the end of October 2020. So everything you see in here was pretty much fast track. So how did we achieve these goals? Well, we set the construction budget, set our project schedule with a move out of October 2020, set the project criteria, the OPRs I talked about, and then we believe we hired the right team. So the first decision we had to make was how about project management? So we didn't have in-house project management, so we interviewed and hired a project management group. And then working with the project manager, we came up with a description for a construction manager. And our idea was to go construction management eventually at risk once we blocked down the scope. And then through the project manager, we worked together and hired the various members of the construction team. This gives you an idea of the site of our new building. We had plenty of parking on this site. It was 11 acres, and then there was a small lake. It was kind of a water retention system in the Georgia area. So that gives you a sense of the building when we bought it. And this gives you a sense of the structure, the existing structure. That's floor-to-ceiling windows, and that domed area in the middle. So that's what we started with. And it gave us basically an upper level that was a good floor plate, and then a middle level was also good. But you can see that we had major losses at the glazing area of the building, so that was something we knew we had to deal with. So the very first thing we did was work on the envelope. So the primary envelope factors were really, we wanted the appropriate window-to-wall ratios, and it's important to define the optimum area. We had to deal with air infiltration and the insulation of the building, so we reduced the windows to get a better window-to-wall ratio, and we glazed we refitted the exterior of the building with insulated material, and sealed the building as well. And this gives you a sense of the daylight patterns for the existing building. And as I said, we had to work on the window-to-wall ratios, and we did. And we found that we would get the best results if we had a window-to-wall ratio of, on the east and west of 33.9, and the south and the north and south of 41.9. So because of the solar impact on the building, it was easier to increase the size of the windows on the south side there. So it gives you a sense of the daylighting approach. So our next phase was, if we want to have daylighting in most of the areas, we looked at skylights. So we looked at a number of variations of skylights, everything from 25 and settled on the 18 skylights as being the main choice. So doubles the daylight on the floor area, and provides useful daylight illumination to 70% of the work areas. So the interior zones were more meeting rooms and service areas. And we raised the windows so that we could have daylighting in the more appropriate angle into the building, and made sure our interior design layout had all the workstations around the perimeter of the area. So that way we could truly utilize the daylighting. And this gives you a sense of the daylighting patterns, so that on the upper level we had 57% of the area was received the daylighting. On the lower area it was, like I said, 33%. But again, we put all the workstations closer to the windows so that they got most of the daylight, and then the other service areas and the training center were on the other area. So what did we get here? So we got our air window, our envelope was sorted out, and so we had an area to get it down. And then the next thing we did was we focused on HVAC in our system. And so we had two options. One was like an all-air system, so we would have heat pumps and provide hot and cool air to the building. Or the other one was a hydronic system. We felt that the hydronic system would give us a better indoor environment for our staff and visitors. So we chose to go with that option. And so we ended up with the hydronic system, as I said, smaller modular control, simultaneous heating and cooling, heat pump and or heat recovery machine. So a heat recovery chiller was utilized, decouple the temperature from humidity. So we had a DOAS unit that would provide reduce the humidities in the building and provide 1.3 times the minimum ventilation air, 62, and also had a heat recovery wheel within the unit. Have stage pumping, water source heat pumps for transient or potentially humid spaces, so there were some water source heat pumps throughout the building, and overhead radiant panels for heating and cooling. Now this was a big decision for us because we felt that radiant panels would provide the best environment because you could minimize that, you could make smaller zones to keep the occupants more comfortable. The problem was in Atlanta, people had never installed radiant panels, heating and cooling panels, so there was a premium that we ended up having to pay for that, but we felt it was very important to use that technology because of the results of it. So that ended up being a decision that we made to handle that. So it gives you a sense of the DOAS unit and the radiant panels. The other thing we added to the building, again for comfort, was ceiling fans. And so our plan was to raise the temperature of the building to operate at about 78 degrees Fahrenheit, and then with the ceiling fans, with the air motion, people would still be comfortable. It's similar to as if you ran it at 75 degrees. So that was a strategy for us to reduce the energy consumption, but maintain the comfort levels. This gives you a sense of what was going on in terms of the DOAS system. The air would come in, the heat pump would do it, and then the air would go up to the various areas and be controlled by air valves. And then the air would come back, exhausted, transfer the heat transfer the heat at the heat recovery wheel, and then exhaust it. And then for the hydronic part of it, we had the outdoor air heat recovery chiller. So we had a heating circuit and a cooling circuit, and it would go to these 6-way valves at the radiant panels, so we could control the heating and cooling individual areas. And the exterior was heating or cooling, and the interior was cooling only, so that we could provide a solid heating and cooling system for the building. And the other area that we had to deal with was our training center, and so we did a displacement ventilation methodology in the training center, so radiant panels with displacement ventilation to maintain that space for the larger groups that come and go in the spaces. And the radiant panels that we talked about were really clouds in the various areas. So to give you a sense of the picture, so they were sort of clouds with the open ceiling behind it. So there was kind of less materials used in terms of ceilings, and the access between the clouds are open to the structure. And then, as I said, we have the ceiling fans to air mixing, reduce capacity, and then we also use fabric duct to distribute the air throughout the open spaces. So it just sort of gently provided the air through those spaces. As you can see, the green represents the fabric duct. So, where did we end up? So with all these things that we did with the envelope, with the lighting, LED lighting, the design team said that we should hit 18.5. Remember, our target was 21.4. So the design team said with all their modeling, we should hit 18.5 BTU per kilowatt per year. So that, we were pretty happy with that result. And to give you a sense, this is the final layout of the workstations and the service rooms, the meeting rooms, and the service areas. We took that dome off, we cut the roof down, created a flat roof, and I've got a picture of that space later on. And this is that middle level that I said didn't have as much daylighting, but most of the daylighting is where the workstations are. And then we had our meeting areas and training center spaces. Our largest training room actually had no windows because we were built into the edge of the side of the hill. So this is how we actually have the majority the lighting for our staff. Now, I talked about that lowest level, and this is the space that was down there. The blue is a mechanical space, and the rest of it is area that we can use for storage and other materials processing space. So this gives you a sense of once we gutted the building, we started to rebuild the interior zones, so it really was gutted down to the structure. One of the things we did very early on was the facility condition assessment, so we understood what systems needed to be replaced. We did get one surprise in that. We thought that the fire sprinkler system would be okay, but it turned out it wasn't. It was a bit of a major upset in our budget, but most of the other systems we knew what we could use and what we had to replace. This gives you a better sense. So that dome there, you can see has a flat roof, and it was being constructed at this time. And we're able to build into the facility a deck that overlooked that lake, so that we have a space for people that are visiting there and for staff to go out and get some fresh air and have a good view. This gives you a sense of the outdoor services for the chillers, and then really a very simplified mechanical room because of the hydronics, mostly pumping and heat exchangers, because the DOAS units were providing the ventilation system from the roof. And as we were finishing the building, it became a much more open concept, and you can see the glazing was reduced, but still gave plenty of light and a feeling of connection to the exterior. Gives you a sense of the outdoor. So just to give you a sense of where we started with a pre-design budget of 15 million. Mid-design, before we found out about the sprinkler system, we thought it would be 18, but the final budget was 20 million, with a contingency of 429,000. That's an important number, because with that number we could actually look at photovoltaics. So we got a price on the photovoltaics, so the total for that was $550,000. So we took our 429, got a little bit more money from the board, and installed what you see here in the photovoltaics that serve the building. 250 kilowatt capacity. So now this gives you a sense of how we're operating today. So the red is the energy produced by the photovoltaics. The blue is sort of the net energy, so energy going into the grid or energy being used by the building. So you can see that we're pretty much tracking right on the net zero line. So key design features were 18 skylights, radiant ceiling panels, overhead fresh air distribution, 6 water source heat pumps to serve those areas that were sort of non-traditional, building automation system, robust IT backbone, demand control ventilation, and on-site electric vehicle charging. So it's built. Now what? Well, now we've got to worry about operations. So we're tracking towards a smart building. We have to do a few things with connecting some of the automation systems. We've also used some building analytics and fault detection for the building to sort of see what issues are coming up in terms of operation. We are going to, in the near future, demonstrate the use of automated system optimization. That's where the analytics starts to say, well, this is how you should modify your building operations to be more efficient, create a better environment. Building EQ evaluation, and I'll talk about that shortly. We have some IEQ monitoring, not an overabundance of it, but we have some. And building intelligence and valuation is something that we have in the works. So I talked about ASHRAE's building EQ, so it's this free web-based portal, if you don't know about it, benchmarks energy consumption, calculates building EUI based on climate zone, and provides data to improve energy performance. And operation assessment is what we really relied on. It uses metered energy, reflects how the building is designed, used, and operated, and its most common application. And so how are we doing? So this was the latest building EQ rating. So -6 means we're below net zero at that moment in time. And this goes back to January of 2024, so look at the 12 months up to January 2024. And so we have a very good building EQ rate. Automated systems optimization, I think I talked about that already. And so what programs are we considering now to review our operations? So we're working with the Building Owners and Managers Association to look at their 360 program and see if we can apply to our building. We're most of the way down in Green Globe's evaluation of the existing building, and we're also in discussions with LEED about existing building operation and maintenance. So these are the things that we thought we would not do, but now we have a working relationship to do that. And very quickly, this gives you a sense of what we achieved in terms of our goals. The one that we don't really know about yet is the water efficiency, because we didn't do LEED yet. But most of these we were able to achieve. So conclusions. We need to design for effective operations. We can't just design, we have to be thinking about how is this building going to be operated and design towards those ends in the occupants. Well, and you need to know your local construction market. For example, that the radiant panel decision, we found out from the construction manager that that was an issue, but we decided to go forward anyway. Carefully examine all the building systems. I talked about the facility condition assessment. And coordination equals communication, and communication was important. We had a number of sessions where we talked about the design and systems with the project managers, the construction managers, our team, to make sure that we had the outcome that we expected in our building. And do not drop the ball after completion. Really, we really need to find ways to improve the operation. To that end, ASHRAE has created a Designing for Operational Excellence guide that's now available. And the key components of the guide are best practice design processes, total cost of ownership, key performance indicators, sustainability, the operator mindset, and Internet of Things and operational analytics. So this is sort of a story of hospital development and a building beyond its useful life and being reinvigorated. And with that, I am.
Any questions? One or two short questions, please.
Thank you for the presentation. It was really interesting. I was looking forward to that. One question, and please ignore excuse my ignorance. What's the kBTU per square feet in kilowatt hours per square meter? And whether the target was for space heating demand only, space heating consumption, or total primary energy, the target associated? That's probably the easy one. It's not the difficult one next. And also that through the steps you follow, you presented some savings by introducing mechanical ventilation. I do get a lot of questions from architects, although I'm an architect myself, that say if we introduce mechanical ventilation, we will have more energy consumption. And I'm proving that no, with mechanical we do have some savings, but can you talk about this a bit more around, I don't know, is it with heat recovery what you were presenting, or just with mechanical?
Sorry, one question please, and the short answer, because we're running out of time.
Okay, first of all, I don't have the actual comparison to kilowatt hours, but three times, roughly speaking. You talked about mechanical ventilation. We wanted to make sure that we provided the air to the spaces that it needed to be. There was heat recovery. There was another question in there that...
Whether it was for space heating only or...
No, it's total energy. The building was all electric, Matter of fact, I had a standby generator, a diesel generator when we bought it, and we actually got rid of that. So it's all electric and it's all the energy flowing to the building, including the electric charging stations for the electric vehicles.
It was sun.
Hmm?
The sun, not the source.
No, yeah, it's site, that site, yeah, total site.
It's fine.
Thank you very much.